I'm going to speak about one of the features that Red Hat is adding to OpenSSL for some time. Yeah, we started that process, and the first implementation was added in OpenSSL 3.5. Of course, post-quantum cryptography was more important, but I believe that adding the opaque object for symmetric keys also has brilliant perspectives. So, what's our motivation for adding opaque objects to OpenSSL? First, there are a lot of support of hardware-backed keys that can't be reasonably represented as a row bytes array, which is a common way of representation of symmetric keys for OpenSSL and for many other crypto libraries. PKCS1, PKCS11 tokens, HSMs, TPMs, processor enclaves, you name it. All of them provide extra security, making keys unreachable for the libraries for the software, but allowing to implement calculations using them. And when we started implementing PKCS11 provider, I believe you attended Jakub's presentation today, we found that, well, OpenSSL can't work with the unextractable hardware-backed keys. One more motivation is well, pure software-based. There are requirements. I don't know, should we consider it obfuscation or should we consider that it provides real security? That the naked keys should not be allocated in memory, so you may want to keep these keys either masked or blinded or, well, mixed in some different manner. Again, you name it. But it's basically undoable with the current OpenSSL implementations. In the pre-3.5 period, well, you could somehow implement very custom method. You could export handles or row pointers to some objects and pretend that it is a key. But it was basically a set of hacks, and there were no good options to do it in a universal manner. Now we are moving step by step to implement it in OpenSSL-friendly manner. In OpenSSL 3.5, we added support for providing awake objects for symmetric ciphers and MACs. And in OpenSSL 3.6, we managed to land UPSK derivations in for using KDF mechanism, using K-exchange mechanism, and it means that now it's usable with real-world hardware in real-world applications. When I came to the idea that we should have opaque objects, not I, of course, not only I, my first intention was to reuse UVPPK object. When I published the design, the colleagues from both OpenSSL and Red Hat told me, no, you should not. UVPPK has 20 members. It has been growing since a very early version of OpenSSL, forget it. So you see now that UPSK structure that we introduced has basically four fields. Two of them are used for reference count, and two of them are responsible for real data processing, the void pointer to the provider-specific K data, and a pointer to UPSK management. UPSK management, sorry, okay, got next. So what can you do with UPSK? Yeah, you can generate it. Yeah, You can import them in various manner. Currently we have provided 3 functions, and probably in some future we will either combine it or deprecate some of them or extend some of them, who knows, but for current implementations that's enough. You can try to convert the existing UPSK to a different provider, and you can try to get their data from the UPSK object, but of course, if the key is hardware backed and not exportable, you should fail. When designing API, we decided not to follow the UPPK approach when you allocate the object and then assign some value in this or that manner. So you have just one-shot operation for creation of fully usable UPSK object. UPSK management structure is a provider backend for UPSK object, and they implement the operations that I enumerated on the previous slide. So you see here are very basic structures. Of course, you should be able, you need to properly free the associated data. So this part of the structure has nothing interesting. Here is much more interesting part. You see that you can get the list of parameters necessary for import for the particular provider. It's convenient, usable. You, of course, have import-export functions. You, of course, should be able to get the generation parameters. And one of controversial decisions is a function getting keyed. It's a function that returns provider-specific printable string by design, because in real world and in, for example, command line application, you may want to get some printable information about the object. Yeah, this part of API is a subject to improve, but now it is suitable for at least minimal understanding what object are you dealing with being properly implemented. The UPSK management API basically consists of some standard functions. Yeah, for every provider backend functions, you may want to fetch it, upref and free. You need to know the provider because you heavily rely on knowing the provider and matching the provider to the provider of the algorithm you're trying to use, the symmetric keys. You have also some more standard accessors. So, what are the guidelines for implementing UPSK management? Yeah, you can use basically one UPSK management per provider. It's a reasonable approach, if I'm not mistaken, but I did not check. It's implemented in PKSS 11 provider. You may want to implement some sort of inheritance. Yeah, for example, what we have in OpenSSL is generic secret object and IS object, which provides some extra checks that the opaque object length of the byte buffer matches the requirement we have for IS. So for expert, for expert support, you can provide some callback functions similar to the arguments of UPPK export. For example, if you have a store which is password protected, this is the way to for application to get to request the password and pass it down to the stack. And of course, when you export, you can try to access the raw data, which is not always acceptable, not always implemented, and speaking frankly, should not be always implemented. Or you can request for, well, parameters that, from my point of view, should contain some basic identifier that, for example, in case of PKCS 11 provider, which is basically the reference implementation as of now, they should contain PKCS 11 URI, so you could rely on this, and operate the opaque object without real extraction of byte. Okay, that was the API changes that were implemented for the support, but it's not enough to support, it's necessary to use them. For UEP Cipher, we have implemented the UEP Cipher SK API, which is quite similar to UEP Cipher init. Sorry, UEP Cipher init SK, yes, with two amendments. One is obvious one, that instead of pointer to a key buffer and its length, we pass the opaque object. And the second is a minor but important fix that for the classical UEP Cipher init functions, there was no way to provide the IV length. And if I am not mistaken, we even had some CV for this because of lack of this information. During the dry run, my colleagues asked me if it's worth passing also the IV in the UPSK format. Technically, it's doable. We can implement this approach, but I don't think it makes any sense for the public data. But of course, if some backends provide the IV or similar data for in a format that are already SK friendly, it can be done if you find a real world use case. The UP Mac init SK function is even more simpler. Yeah, again, it just replaces the K buffer with length to the pointer to UPSK objects. So again, the backend part is quite obvious. You have a pair of encrypt-decrypt SK init functions for the cipher, accepting void pointer corresponding to the data, and similar extra callback for the UEP Mac backend. In 3.6, as I mentioned, we have landed several more functions to make the usage cycle of UPSK object more relevant. For UPKDF API, we have implemented two functions. First, we implemented the function UPKDF CTX set as key. Sorry, because some KDFs has parameters that are sensitive, and it's worth having the opportunity to provide these sensitive parameters in a non-extractable way if we have a way to derive it in this manner. And of course, the UPKDF derivers key that gives us the UPSK object, which then can be used together with Cipher, UP Cipher, UP Mac, and so on and so forth. For UPK Exchange API, we have added only one function, UPPK derivers key. It's similar. So let's look at the backend part. The backend part, again, I made a design decision that probably is controversial. The derivation functions accept two parameters that would be used for properly creating and verifying the object on the provider level. So you can either provide, well, not either, you can provide the key type for the case when the provider implementation refers on key type to distinguish if the properties of the generated as key matches the algorithm requirements. Or you can trust that UPSK management import function is suitable to deal with it. Again, UPSK management function is algorithm specific. Again, returning back for the OpenSSL implementation. Yeah, if you derive 25 bytes key using any derivation functions, you can use it as a generic object, but obviously you can't use it for IS just because of length. So you need to make the check. The only place you can do this check is provider level, and the only functions that makes this check at the provider level is the import callback of the UPSK management. Of course, when you introduce a new API, you have to think about the sort of old implementations, yeah, because people will use existing providers. For example, they will use certified FIPS providers and try to use new API. So we do our best to make sure that if the key is available in traditional row-based representation and the symmetric key callback is not implemented, it will be suitable to fall back to old implementation if it's provided. But this fallback mechanism use internally UPSK get zero row key or UPSK import to try to access the row-based representations. When I was preparing this presentation, I found out that I was not as consistent as I wanted to be. So again, looking forward and waiting for real-life scenarios, I think there is a place to groom, and I hope that community will join the process. For new implementation, we recommend having both callbacks when it's appropriate, either do something or do something as key. And it will be safe enough. And if you use old build of OpenSSL with the new provider, the new callbacks will not be visible on initializing the provider, and nothing bad happens. There is a potential problem when you have UPSK from one provider and algorithm implementation from a different. There is no way to deal with it. Otherwise, then try to perform export-import dance to get row-based representation. Sorry, it's the quite natural limitations, and I don't see any way to resolve this issue. Okay, that was the description of what we have already done. Now let's look for the reasonable next steps. The nearest obvious step is implementing of storage support for UPS keys. I have a pull request for it. Oh, I forgot to add the number, to add the link of it. Sorry for that. There is no format specification for symmetric keys. Yeah, there is basically zombie RFC 6031. When I asked an author if there is any implementation of it, I got answer, well, there is one private, yeah, and I think that we should not bother implementing it in OpenSSL. There are ways to provide a special type of bag in PKCS 12 format, and it may be reasonable to implement it in some future. Well, the other problem is that basically any sequence of bytes, even if it's parsable as, for example, a normal encoded private key, can be treated as a symmetric key, right? So to deal with it properly, I decided that when you try to read the symmetric keys from a file, you should have some reasonable limitation of the length of this key. I set it to 2048 bytes. You should explicitly request that you are reading the EVP SK, that you are reading the symmetric keys from the file. Yeah, it's a place that I would like to get the community feedback. I think it's natural to be able to read a key from file, probably in several representations. Paul Dale mentioned raw bytes, hex representations, and base 64 representations. It may need the changes to the store API, maybe some specializing the store, maybe some store parameters. I think we should do it. And for PKCS 11, you can just specify the URI and it will just work. And I have tests in PKCS 11 provider that will be automatically run when the store API is merged. I hope I will get reviews from the OpenSSL committers. Unfortunately, before the conference, I didn't manage to get it. To simplify the testing, I added some basic support to OpenSSL command line utilities. Of course, the simplest was for OpenSSL list. You can list the SK managers belonging to the particular providers. I added a very basic implementation of OpenSSL SKUtl inspired by OpenSSL PKUtl. It has currently very basic operations. You can provide the SK management, some options, and the only thing it can do is key generation. But now when we have landed the support of key derivation, I think it should be expanded. To test that keys are suitable for encryption, yeah, we added support of the several options to the UP-enc option, to the UP-enc utility. So you can specify SK management and the set of SKOpt, and you will get, if I remember correctly, you will generate the key at the matching the requirements, or generate is in a wide sense, yeah, one of the parameters can be a raw byte representation, for example. And you will see that when you provide this implementation wrapped in this manner, you get the same results as you would get if you use just this raw bytes. And after the storage changes land, we will get two more options to provide the password for accessing the key that is in the protected store. And again, after the store is going to land, you will be able to list the opaque objects stored in the particular store specified via the storytell command. Known implementations. Of course, we started from OpenSSL. We landed the generic secret and AS secret in the default provider in 3.5 and added them sorry, to the legacy provider and FIPS provider in 3.6. For the test purposes, I added some dummy implementations for PBKDF1, KDF, which is a part of legacy provider, and ECDHK exchange, so you can test that they're doable with the default provider. They keep the keys, basically in octet string-like format, but it's suitable for testing. Of course, real-world providers with real-world hardware-backed keys should have some more sophisticated backends. I mentioned OpenSSL provider many times. So here is the most reasonable support of the opaque objects. There was a presentation made by my colleague Jakub Jelen today about the OpenSSL provider, and he mentioned the support of Symmetric keys there. There will be a presentation by Holger, if I'm not mistaken, on Thursday. That implements hardware-backed keys in a provider that is different from the OpenSSL provider. So it means that the presentation is not. It means that implementation is not this bad. It at least passes smoke tests. So what to be done? Oh, I have a link to the story PR. So please keep the link, and those who can review, those who are ready to give feedback, please do. Some future. We probably will need encoders, decoders support, or not, who knows. And from the OpenSSL provider perspective, we will need to simultaneously derive several keys from KDF, which is necessary for proper TLS implementations. When you derive 2 or 4 keys from the one input, you can't just derive, if the key is not a byte buffer but opaque object, you can't just derive and chop it into parts, which is currently done in the code. And well, who knows, yeah, in some future, not so distant, you may want to use only opaque objects through the library. It can give you probably better security, or not. Probably at the cost of some performance loss, but I don't think it will be really significant. Okay, so this is the last slide. I added it just today because during several pre-conference meetings, I heard the interest of dealing with the symmetric keys object. So I think that it's worth creating the special interest group dedicated for moving the UPSK API forward. We have the API perfectly matching our Red Hat needs from the OpenSSL provider perspective, but other implementations will need something more. Okay, thank you very much. I also want to give personal thanks to the people from OpenSSL team who reviewed my PRs, and to my colleagues who implemented the counterparts in OpenSSL provider, who participated in runs of my presentation and gave much appropriated feedback. Thank you very much. Feel free to ask questions.
So, I might create an AES key for encryption and then accidentally use it as a MAC key or vice versa. Why aren't these keys associated with an algorithm that's the only one?
My understanding is that in real life, you can use you can have a generic case which is usable for any operations. But for example, there are hardware backends that have strict typization, because S11 provider is the typical example of it. So you should be able to set the proper type at the creation. You may not know it, then you have problems, but it's usable.
Nicola Toveri, Tampere University. Thank you, Dmitry, for the presentation. It was very interesting. I wanted to ask you, so you touched a little bit about future plans for TLS and deriving multiple keys. I was wondering, at the moment in 3.6, what is the state of things in terms of using EVPS key opaque objects in libSSL, for example?
It's basically not started because of the reason that API is not designed. I have some ideas how to implement it, and you are welcome to propose your design. Any more questions?
Hi, so I'm late to this talk, but my understanding is that this is about hardware keys and HSMs. Symmetric keys.
To some extent, yes, it's one of the reasonable ways.
It's symmetric keys, and the thing is that accessing keys in a TPM or an HSM or whatever is not that different for symmetric versus asymmetric.
Yes, but it's a question of internal implementation.
Okay, I'm just concerned.
There was no way to provide the handle to get a handle from hardware, okay, non-hackerish way to provide a handle from the hardware-backed device and push it into the cipher. Yeah, you could do it. Programmers are quite inventive, but it was quite inconvenient.
Okay, so the part that is interesting to me is everything to do with authorization and policy to access a hardware key. And those parts are going to be generic. So that's the part that I think is the hardest part to crack.
Please provide your ideas.
Okay.
Again, I would publish a call for creating a special interest group at the OpenSSL community's website. I think I will do it next week. So please follow the OpenSSL community site. Express your opinions, propose your designs. It's the way, it's a good task for the community work, taking into account the amount of interest.
Any more questions? Oh, yeah, we have you.
Dmitry, please also include the question about the file format in that website.
Well, again, I will.
Yeah.
I will. But again, I think that at that phase, Red Hat has provided what fits our purposes, and now the broader community should test it for viability and demonstrate the weak points in the design and provide the implementations.
Thanks.
Thank you. It's me again. I was wondering, with the planned feature about the store API, do you think it will be possible to also support the use case of, let's say, processor enclaves that don't have storage itself, so they kind of encapsulate the key as a backend? So you still have a handle, but then you need to provide the bytes for the CPU to decrypt securely.
I think it's usable. Holger, you can. I think you can answer Nicola's question, and we'll do it on Thursday, right?